So, hello, my dear student. How are you? I hope all of you are well and doing good. So, let's start today's session. That is your lecture number 12. And welding part is what? Welding part 2, right? Welding part 2. So, today we are going to start welding part 2. Yeah. So, let's start welding part 2. Yeah. Yes. So, here in today's session, I'm going to cover electric arc welding. And yesterday, we have discussed a little bit about the electric arc welding, my dear. And now today I'm going to again discuss the electric arc welding, right? So let's start electric arc welding. In the electric arc welding, let's discuss about the electrode, right? Let's discuss about the electrode. Okay, let's discuss about the electrode. Electrode. Let's discuss about the electrode. My dear, electrode are of basically generally we use three type of electrode. One is manually arc weld. Basically, what we do, manual arc welding. In manual arc welding, we use a shielded electrode, right? We use a shielded electrode. So let me write down here shielded electrode, right? We use shielded electrode, shielded electrode, right? We use shielded electrode. Next, we use a bare wire electrode, right? We use a bare wire electrode, bare wire electrode, bare wire electrode, right? And next is your non-consumable electrode, right? Next is your non-consumable electrode. Next is your non-consumable electrode. Non-consumable electrode. Non-consumable electrode, right? Non-consumable electrode. Non-consumable able electrode, right? Non-consumable electrode. My dear, so generally we use three types of electrode: shielded, right? Shielded, or here this is bare wire electrode, right? And here non-consumable electrode, right? Non-consumable electrode. Is it clear? Here manual arc welding, basically, sorry, shielded electrode generally used in what, in where, in manual arc welding. It will be used in manual arc welding. Manual arc welding, right? It will be used in manual arc welding. Here, bare metal electrode will be used in automatic and semi-automatic welding, right? Automatic, automatic, and semi-automatic, semi-automatic welding, right? Semi-automatic welding. So we use these electrode here. And non-consumable electrode, basically electrode is not going to be consumed here. Here both the electrode, shielded metal, shielded electrode or bare wire electrode, both are consumable. Please remember, both are what? Consumable, right? Consumable, right? Both are consumable electrode, right? Which shielded electrode and bare wire electrode. Okay, if you are going to talk about, if you are going to talk about non-consumable electrode, the non-consumable electrode, basically we use here tungsten. Electrode is not going to be consumed here. Okay, electrode is not consumed here. Here electrode is not consumed here, right? Not consumed here. Electrode is not consumed here. So whatever be the gap in between the electrode and workpiece remain constant, or you can say arc remain the length of arc, okay, is constant and stable. So arc and so here arc is stable, right? Arc is stable. Arc length remain constant. Arc length remain constant. Remain constant. Arc length remain constant, right? Arc length remain constant, and here arc length remain constant, so which implies that arc is stable. Okay, arc is stable, right? Arc is stable, right? So the thing is that here the shielded electrode and bare wire electrode both are consumable, so they also act as a filler rod, right? So they also act as a filler rod, my dear. Here they also act as a they also act as a filler rod, right? They also act as a filler rod. Okay, they also act as a filler rod, right? Filler rod. They also act as a filler rod. Is that clear? They also act as a filler rod. Is that clear? Now, if you are using a non-consumable electrode here, right? If you are using a non-consumable electrode here, so how a filler metal you can supply, right? For that we need a separate metal wire. Okay, separate metal wire is used. Separate metal wire. Separate metal wire. Metal wire is used. Separate metal wire is used, okay, as filler, right? As filler. Separate metal wire is used as filler. Is that clear? Separate metal wire is used as the filler. Separate metal wire is used as the filler. Yeah. Now let's move to the next point. Let's move to the next point. So here basically arc welding. The equipment we use in arc welding are drupper, or you can say an constant voltage. So let me write down here arc welding, right? Here arc welding equipment. So let's discuss about arc welding equipment. Equipment. Arc welding equipment, right? Arc welding equipment. My dear, the arc welding equipment is what? There are two types of equipments. Let me write down here. Let me write down here. Right. Let me write down here. First is first is Drupal. Right. Number one. Drupal. Right. In Drupal, current is constant. Right. Drupals. Always remember Drupals. Right. Drupals. So in Drupal, constant current welding machine is what? It is a constant current, constant current welding machine. Constant current welding machine. Right. Constant current welding machine. So constant current welding machine generally use where you do manual arc welding. So it is good for manual welding. Okay. So good for manual welding. Good for manual welding. Yet good for manual welding. So here I of arc equal to I of what? Transformer. I of transformer, right? I of arc equal to I of transformer, right? I of arc equal to I of transformer. Second, second, that is your constant voltage machine. Second, constant voltage machine. Constant voltage machine. So generally constant voltage machine will be used when you do semi-automatic and automatic welding. So good for automatic and semi-automatic welding. Good for automatic, automatic and semi-automatic welding. Semi-automatic, semi-automatic welding, right? It is good for what? Automatic and semi-automatic welding. Here the relation is what? Whatever the voltage is produces in between the arc is equal to the voltage of transformer. The voltage of transformer, my dear, right? The voltage of transformer. So this is the thing, right? So this is the thing. Now here let's discuss about the graph. My dear, let me write down, let me draw the graph. Let me draw the graph of what? Graph of your drooper, right? Graph of your drooper, right? Graph of your drooper, right? Graph of your drooper. In drooper, you have seen that current is constant, right? Constant current. Meaning is that constant current, right? Constant current, constant current, right? Now, if you draw the graph here, please see. If you draw the graph here, see here. If you draw the graph here, this is the graph, my dear. Here on the y-axis, I'm going to draw the voltage, and the x-axis, I'm going to draw the current, right? So here the graph is look like this. Please see here the graph is look like this. See here, this is a graph basically. Or let me draw the complete graph. Basically, this is a graph. Okay, please see. This is the graph. Here, my dear, what we said, current is constant. Suppose that at V1 voltage, right? There is another voltage, let's say V2 voltage, right? Let's say there is another voltage, that is V2. Now corresponding to V1 voltage, my dear, corresponding to V1 voltage, corresponding to V1, and this is what? V2 voltage. Now corresponding to V1 voltage, there will be a current. See, there will be a current. This is what? This is, let's say, I1, right? And corresponding to V2, there will be a current. Let's say it is what? I2. So my dear, it is what? It is I1, right? It is what? It is I1, and it is what? I2. And here you can see that if you are going to change the voltage in a very large amount, then there will be a very small change in what? Then there will be a very small change in what? Current, right? Then there will be a very small change in what? Current. So almost you can say here current is what? Current is constant, right? Almost you can say that the current is what? Current is constant. Now the next graph is what? Next graph is for a constant voltage, right? Next graph is for constant voltage. So let me write down the constant voltage here. Let me write down the constant voltage, right? Let me write down constant voltage, constant voltage, right? Constant voltage. This is what? Voltage, and this is what? Current, right? Here the graph in between the constant voltage and current, let me draw the graph. This is the, basically this is what? This is the, just a minute. See, this is a graph, a straight line, right? A straight line. And what is the meaning here? Let me tell you. What is the significance? Suppose that this is the voltage V1, right? Suppose that this is a voltage V1, right? Suppose that this is a voltage V1, and here this is the voltage, let's say V2, right? This is a voltage V2. Let me write down. This is a voltage V1 and this is a voltage V2. My dear, you can see for a small change in voltage or for a large change in current, right? For a large change in current, there the change in voltage is what? Is small. The change in voltage is what? Very small, my dear. Right. So this is a linear characteristic when you are talking about the constant voltage, right? And it is good for your automatic and semi-automatic machine. Always remember this characteristic hold good for automatic, for automatic, for automatic, okay, semi-automatic, semi, semi, semi automatic, semi-automatic machine, semi-automatic machine, right? Semi-automatic machine. Is that clear? Is that clear? Right? Is that clear? I hope this point is crystal clear. I hope this point is crystal clear. Right? Automatic and semi-automatic machine. Now, whenever this line is touch here, okay, right? Whenever this line is touch here, this voltage is known as open circuit voltage, my dear. What do you call? Open circuit voltage. When this line is going to touch at the current axis, then this is known as short circuit current. This is known as short circuit current. Now you can see that there is a linear relation in between the voltage and current. So this is a straight line having an intercept on voltage and current. So you can write that V divided by open circuit voltage plus I divided by short circuit current equal to 1. So this is the relation, right? So this is what? This is a relation, my dear. This is a relation. So please remember this relation. This relation is very, very important, right? This relation is very, very important. I hope the thing is clear. Now, sometime a student will ask, sir, can you please tell us what do you mean by open circuit voltage? My dear, open circuit voltage is the maximum rated voltage between open terminal under no loading condition. Okay, let me write down here what is OCV. OCV is nothing that OCV, open circuit voltage. Right. So let me write down about the open circuit voltage. It is what? It is a maximum rated voltage. It is a maximum rated voltage. Okay, it is a maximum rated voltage. It is a maximum rated voltage. Okay, maximum rated voltage between open terminals, between open terminals, between open terminal, between open terminals. Okay, between open terminal under no loading condition, under no loading condition, no loading condition, under no loading condition, right? Now similarly, sir, can you please explain the short circuit current? Yes, it is a maximum rated current, right? It is what? The short circuit current is what? It is a maximum rated current, right? That is required during arc generation. Maximum rated current. Okay, short circuit current is what? It is a maximum rated current, maximum rated, right? Maximum rated current that required for that required, okay, that required for arc generation, that required for arc generation, right? Arc generation. Tell me, is that point is clear? If both the points are clear, what is open circuit voltage and short circuit current. I hope both the points are crystal clear, right? Both the points are crystal clear. Now, let me let me give you another concept. Sometime in the exam, examiner wants okay, the condition for maximum arc power. Okay, condition for condition condition for maximum maximum arc maximum arc power, right? What is the condition of maximum arc power? This is a very important topic. Okay, condition for maximum arc power. My dear, we know that arc power equal to voltage into current of what? Of arc. Yes or no? Voltage into current of arc. Now we know that V divide by, okay, maximum condition for maximum arc power in constant voltage. Let me write down completely: in constant voltage, in constant voltage, in constant voltage, right? In constant voltage. When you are talking about what? Constant voltage, right? For a constant voltage, you know that V divide by open circuit voltage plus I divide by short circuit current equal to 1, right? V is the source power voltage and V here is the arc power voltage, and we know that V of arc equal to V of transformer, that is that V, and V of arc is that V. So here you can put this is equation 1, this is equation 2. So here we are going to put V of arc. Okay, so when you are going to put V of arc, divide by open circuit voltage, you will get a corresponding current of arc. You will get a corresponding current of arc divided by short circuit current equal to 1. Yes or no? Yes. Then after that, my dear, after that what you will do? After that what you will do? Then I of arc become equal to what? 1 minus V of arc divided by open circuit voltage, right? V of arc divided by open circuit voltage into short circuit current, right? Now this is, let's say this is the equation. Let me write down here. Okay, this is equation 1, this is equation 2, and this is equation 3. Now okay, from equation, let's say this is equation 4. Now from equation, my dear, 1 and 4, right? From equation 1 and 4, can we write that power of arc equal to V of arc, right? Multiply, instead of I of arc, can I write 1 minus V of arc divided by open circuit voltage into short circuit current? Yes or no? Now for a maximum arc power, for maximum for maximum arc power, right? For maximum arc power, can we write, can we differentiate P of arc with respect to V of arc? Now differentiate P of arc with respect to what? V of arc. Okay, so what you will get? You will get 1 minus twice of V of arc divided by open circuit voltage into short circuit current equal to 0. Okay, for maximum minima we are equating to what? We are equating to 0. Now put it, so you will get V of arc equal to, okay, open circuit voltage divided by 2. My dear, it is a very important condition. It is what? It is the very important condition, right? V of arc equal to open circuit voltage divided by 2, right? Now if you put V of arc here, now you put V of arc here, then you will get I of arc also, right? Also I of arc equal to what? You will get short circuit current divided by 2, right? When you put this value V of arc here, then you get I of arc, that is equal to short circuit current by 2. So always remember, this is a very, very important condition, right? Now, how a question will become? Let me show you the question, right? Let me show you the question. Suppose that this is a question, my dear. Suppose I'm going to ask, okay, here, let's say open circuit voltage is 80 volt, right? Open circuit voltage is what? 80 volt. And short circuit current equal to let's say 300 ampere. Let's say 300 ampere, right? Now, for a linear voltage current characteristic for for a linear voltage current characteristic for a voltage current characteristic, okay, for a voltage linear characteristic, okay, I mean this condition is given for linear voltage characteristic. Let me write down here. One thing is also given, linear voltage characteristic, right? Linear voltage characteristic is linear voltage and current characteristic is given. Then for maximum arc power, for maximum arc power, what will be the arc voltage? For maximum arc power, arc voltage and your arc current will be, yes, anybody tell me the answer? Can anybody tell me the answer? Here the characteristic is linear voltage current characteristic, linear voltage current linear voltage current characteristic characteristic okay, linear voltage current characteristic. Open circuit voltage is given, that is 80. Short circuit current is given, that is 300. For maximum arc power, what will be the V of arc and your I of arc? Simple na? Simply what you can write, V of arc is what? OCV divided by 2. I of arc, short circuit current divided by 2. So open circuit voltage is 80 divided by 2, right? Short circuit current, that is 300 divided by 2. So it is 40 volt. It is 40 volt and it is 150 ampere, right? 150 ampere. So this is our answer, right? This is our answer. So I hope this point is crystal clear, right? This point is crystal clear. So let me write down one more very good question here, right? One more very good question here. So this is a question which I'm going to write down. Please see the question, right? The question is, in a DC arc welding operation, in a DC arc welding operation, right? In a DC arc welding operation, right? The voltage arc length characteristic, the voltage arc length characteristic characteristic the voltage arc length characteristic was obtained as right was obtained was obtained as, okay, what? V of arc equal to always remember, your voltage arc characteristic is a function of arc length, right? That is 20 plus 5L, right? 20 plus 5L. Here, remember that L is what? Here, L is your in mm. L is what? L is the arc length. L is what? Arc length, right? Arc length. arc length, it will be in mm. Always you put in mm. And V of arc is the arc voltage, right? Arc voltage, right? Arc voltage, and it will be in volt. It will be in volt, right? Now here L is very, L is very, L is very in between 5 mm to 7 mm, right? Arc length is vary from 5 mm to 7 mm. And according to that, your current, arc current is also vary, right? According to that, your current varied from 400 ampere 400 ampere to 500 ampere. Is that point is clear? Now, assuming linear power source characteristic, we have to assuming assuming linear assuming linear power source characteristic linear power source characteristic linear power source characteristic, right? The open circuit voltage you have to find, we have to find you have to find open circuit voltage. You have to find what? Open circuit voltage and short circuit current. That thing we have to find. Is that question is clear? Is that question is clear? The question is the question is pretty simple. In a DC arc welding operation, the voltage arc length characteristic was obtained, right? Here V of arc equal to 20 plus what? 5L, right? L is arc length, that will be in mm. V of arc equal to arc voltage, that will be in volt. Here arc length will be 5 mm to 7 mm. Here arc current is what? 400 ampere to 500 ampere. And assuming linear power source characteristic OCV comma and short circuit comma, right? Now, so we have to solve this question, my dear. So here I'm going to solve this question. Please see on the next slide. I'm going to solve this question. Here on the next slide, I'm going to solve this question. See here. See here, this is the voltage, as you know, and this is the current, right? And this will be the line, right? And this is open circuit voltage, short circuit current, right? Now, when you put L equal to arc voltage, right? Arc voltage. Now find out the arc voltage when L equal to 5 mm, or little bit I'm going to write down. When L equal to 5 mm, right? Then V of arc equal to what? You know that 20 plus, we know that 20 plus 5L, right? 20 plus 5L, and L is what? 5, so it will be 45 volt, right? Now if L equal to 7 mm, right? L equal to 7 mm, V of arc 20 plus 5 into 7, so it will be 55 volt. Now here the voltage is 45 and 55, right? That is what 55. Corresponding to that, you will get current this, and let's say this is what? Let's say this is, right? This is 45, right? And this is 55, right? 45, 55. Corresponding to that, we will get current. So here, corresponding to 45, the current is less. Corresponding to 55, the current is more. So less current is what? 400 ampere. So here, write down 400, and here 500. So my dear, here you can see a straight line equation which has two coordinates. Can you see a straight line equation which has 2 points? So can we write down the coordinate, that is 400 comma 45, right? That is coordinate number 1. 500 comma into comma 55. So this is a point number 1 and 2. Is that clear? This is a point number 1 and 2, right? This is the point number 1 and 2. So here you can write the equation of line, right? What is the equation of line? Equation of line. So the equation of line is pretty simple here. Equation of line, pretty simple. What is the equation of line? This is, you can write down V2 minus V1 divided by I2 minus I1 equal to, right, V minus V1 divided by I minus I1. Remember the equation of line? Okay, I will write down if you are not remember. What is that? Y2 minus Y1 divided by X2 minus X1 equal to Y minus Y1 X minus X1. Right. So similarly, you can put the value here, right? So V2 is what? That is your 55, right? That is your 55 minus 45 divide by I2, that is 500 minus I1, that is 400 equal to V minus 45, right? V minus 45, 55, V2 minus V1, yes, and I minus 400, right? So this is the equation. Now solve this equation. 55 minus what? Am I right or wrong? I think there is little bit, I think. Let me check the thing. Just a minute. Here y2 minus what? 55 comma 500. Okay. Oh. Sorry. Yes, this is a 45 and this is 55, right? So this is 45. This is 55. Yes. So yes, now the thing is clear. Clear now? Clear now? Now the thing is clear. Again, I'm going to write down. Please see here. Here, this is what? 400 comma 55, 500 comma 45. Point number one, point number two. Right now, 45 minus 55, right? 45 minus 55 divided by I2, that is 500 minus 400. V minus V1, that is 55. I minus I1, 55. I minus I1, that is 400. Now 45 minus 55 minus 10 divided by 500, 400, that is what? 100 equal to V minus what? 500 divided by I minus 400. So this cancel. So here V minus 55 equal to minus of I minus 400. Now multiply by 10, right? Multiply by 10. Now you can solve this. So it is what? 10V minus 550 equal to minus I minus plus 400. So 10V plus I equal to 400 plus 550. So it is 950 10V plus I, right? 10V plus I, 10V plus I. So this is the thing. So you can write down in the intercept form, my dear. So 10V. So divide by V divided by 95 plus I divided by 950, right? Equal to 1. Equal to 1. Right? Equal to 1. So if you compare the equation is what? V divided by open circuit voltage plus I divided by short circuit current equal to 1. If you compare these equation, from this equation we can write that open circuit voltage is 95 volt, right? And short circuit current equal to 950 ampere, right? So this is our answer. This is our final answer, right? This is our final answer, right? This is our final answer, my dear, right? So now let's discuss some other points also. Now let's discuss the concept of heat input. Let's discuss the concept of heat in, right? Let's discuss the concept of heat input, right? Now the concept of heat input is pretty simple. Now see here, this is your Okay, the welding base plate which you are going to weld, right? See here, this is the weld pool. This is a weld pool. Here you can see if I'm doing the welding, right? Here I'm doing the welding, as you can see. Now here, this is your electrode, and the electrode is moving with the welding speed V, right? With the welding speed V. Here V is the welding speed, right? V is the welding speed. Let's say it will be in mm per second, right? And if capital V is the, let's say, arc voltage, and capital I is the arc current, right? Then the arc power, right, which is going is what? P, and it is what? V into I, right? V into I. So the heat input, basically, heat input generally measure in per unit length, right? In per unit length. So my dear, the heat input equal to arc power transverse welding speed, right? Welding speed, welding speed, welding speed, right? Welding speed. So here the unit is what, my dear? Watt, right? The unit of is what? Watt. So arc power is what? V into I divided by welding speed. So it will be in joule per mm, right? Joule per mm means per unit length we are providing that much heat. So in short, I am going to write heat input, that is HI, right? So this is the heat input. My dear, if the heat input is same in different weld, right? If the heat input is same in the different weld, then the quality of joint is also same in the different weld, right? The quality of the joint will same in the different weld, right? Let me show you one more question here so that you will understand the thing in a very well manner, right? In a very well manner, right? A linear power source, a linear voltage current characteristic, right? Here the characteristic is what? Linear. VI characteristic. Linear VI characteristic. So in short, I am going to write linear, linear, linear VI characteristic. Characteristic, right? VI, linear VI characteristic is given, right? In question, open circuit voltage, short circuit current, both are given. What is that? 62 volt, right? 62 volt, and the short circuit current is what? 130 ampere, right? 130 ampere. Next is that arc length is given. Here arc length will be in 4 mm, right? Arc length will be in 4 mm. Traverse speed of welding, traverse speed of welding, traverse speed of welding, right? Traverse speed of welding equal to what? That will be 15 centimeter per second. 15 centimeter per second, right? 15 centimeter per second. Efficiency of heat input, right? Here, efficiency of heat input is given. Efficiency of heat input is what? 85%. 85% is given, let's say, right? Efficiency of heat input uh, camera getting blurry. Okay, efficiency of heat input is 85%. Voltage is given. Voltage, okay, voltage is given as right. Voltage is given as what? Voltage is given as V, that is equal to 20 plus 1.5 L, right? 1.5 L. My dear, we have to calculate heat input into the workpiece. Heat input, heat input into the workpiece, into the workpiece, right? Into the workpiece. So we have to calculate the heat input into the workpiece. So here, V of arc. What will be the V of arc? V of arc will be 20 plus 1.5 into L. L is what? L is 4 mm. So 4 mm, right? L is what? L is the 4 mm. Yeah. So 20 plus 1.5 into 4, 26 volt. 26 volt. Now what will be the current? We know that we know that V of open circuit voltage plus I short circuit current equal to 1. V of arc 26 open is 62 plus you are getting corresponding I of arc divided by short circuit current 130 ampere equal to 1. So 1 minus 26 divided by 62, right? Answer into 130. So here I of arc is here I of arc is 75.48 ampere. So so arc power is V into I, right? Arc power. It is what? It is 26 into 75.48 watt, right? Watt. So this is the thing. Answer into 26. So here this is 1962.58 watt, right? Now this is a theoretical. Now heat input basically is what? 1962.58, right? Divide by welding speed, that is what? 15. So it will be what? Joule per centimeter. So answer divided by 15, that will be 130 joule per centimeter. My dear, this is a theoretical. This is what? This is theoretical. There is a efficiency, means you are giving that much, but actually going this much, right? Actually going this much. So actual heat input equal to 130 point. It is 130.8. 130.83 into 0.85, 0.85, right? Answer into 0.85. It is 111.21 joule per centimeter. Joule per centimeter. So this is our perfect answer, right answer. Okay. Okay then. Thank you very much for watching this session.